Lesson 8.7. The goal is to find the circumference and area of circles. So thus far in Chapter 8 we have learned about squares and rectangles, parallelograms, rhombuses, triangles, and trapezoids. Now we want to talk about how to calculate the area of circles as well as the circumference. So a circle is defined as the set of all points in a plane that are the same distance from a given point. That's called the center of the circle. The distance from a center to the point on the circle is the radius. So if I pull up my circle tool, you can see this circle, and we can identify the radius of a circle by drawing a segment from that point to the outside of that circle, and that would be the radius. So this is a circle. You can tell that anywhere I draw that radius, it should be the same distance to each of the points on that circle. So that makes it a radius and from the center. The distance across the circle through that center is called the diameter. So if I draw that, the diameter goes all the way across, and it connects 2 points on the circle, diameter. But it goes through the center to do that. So the key is that it does go through the center, and it's the distance across the circle, the diameter. Now, what is the relationship between the diameter and the radius? Well, the radius will always be half of the diameter, or the diameter will always be double the radius, as you can see in the picture above. Circumference. Circumference is like perimeter on a polygon. It's the distance around a figure. The distance around a figure is always called the perimeter, but in this case, with circles, it's called the circumference. That's the distance around a circle. The next vocabulary word is central angle. And a central angle is what it sounds like. It comes from the center of the circle. And so you're going to have an angle formed inside the circle by 2 radii. So we've got 2 radii that form this central angle. The central angle is the angle formed by these 2 radii that comes from the center. So this is a central angle. A region of the circle determined by 2 radii, and part of the circle is called the sector. So this central angle that was formed by 2 radii forms the part of the circle that's called the sector. So if I want to get this part of the circle, it would be called the sector of the circle. Now, we want to know how to calculate the circumference of a circle and the area of a circle. So the circumference is always going to be pi times the diameter, or since we know the radius is half of the diameter, we can do 2 times pi times r. So you can see it written as pi d, or as 2 times pi times the radius. The area of the circle, remember when we talk in terms of area, we always include square units, and this is the way that might be easy to remember the difference between circumference formula versus the area formula, that the area is pi times the radius, but it has this squared term for area, pi radius squared. Alright, so it says find the circumference of this circle. Remember, circumference is that distance around this. We have 2 formulas we can use. We can use pi times d, or we can use 2 times pi times r. In this case, since they give me just the radius, I can calculate the circumference by doing 2 times pi times the radius. And so we'll substitute 7 for the radius, And simplify. 7 times 2 is 14. We'll leave pi out to the side here. Pi is an irrational number, so we use this symbol to represent that lengthy number that is irrational. And now we can use 3.14 as an approximation for pi. If you look at the back of my classroom, you'll see that long number that represents pi, and it goes on infinitely, and it has no pattern. So we can use 14 times 3.14 just to round. And so we get the value 43.96, and so the circumference of the circle is about 44 meters. Don't forget your units. So take this moment to try to do exercises 1, 2, and 3 to go along with example 1. Okay, for number 1, we can see that they give us the radius like they did in the example, so we're going to use the circumference formula, that is 2 times pi times the radius. So here, the radius is 2 inches, so 2 times 2 is 4. We get 4 pi, and so again we can use 3.14 just to approximate pi. And so we'll say 4 times 3.14. That gives us a value of approximately 12.56. And so if we round to the nearest whole number, this will round up to 13. And we're talking about inches here. Next, number 2, they give us the radius. It is from the center to the edge of the circle, so that's the radius. We'll do 2 times pi times the radius. 11 times 2 is 22. And if we use that 3.14 as an approximation, we will get approximately 69. We'll get the circumference to be approximately 69.08. And that will round to 69 if we're rounding to the whole number, centimeters. And number 3, this time they give us the length from 2 points on the circle that goes through the center of the circle, and that makes this the diameter. So the diameter is 28, so we can use the circumference formula that uses diameter, which is pi times b. So that would be pi times 28. And if we use 3.14, 28 times 3.14 will give me 87.92, which will round to 88 yards. Alright, next. Switching gears to area of a circle. So this time we want to know, well, what is the space that the circle takes up if the radius is 6 feet. So we'll just substitute that in for r, 6 squared. So pi times radius squared. We get 36 when we square 6. If we use 3.14 to approximate pi, we would say 36 times 3.14, and that would give me 113.04. This time they didn't tell us to round any particular way, so we could leave it like this, and don't forget your units. And it's no longer just feet now that we're talking about area, it'll be square feet. Take this time to complete 4, 5, and 6, calculating the area of the circle. Round to the nearest whole number. Alright, so the area for a circle is pi r squared. We have the radius, and this one is 17. And we want to square that 17, and we get 289 pi when we do that. And this is in inches, so it'd be square inches. Now, typically, this would be the answer I want because it's an exact answer. Pi is an irrational number, so it makes it in a nice, exact number, and it's in a condensed form. If I want you to round to the nearest whole number, you would just type in 289 times 3.14, and we're going to get 907.46. This would, since this number is not 5 or above, we will round to 907. And we're talking about square inches for this. Next, number 5. They give us the radius again. So we'll substitute 5 centimeters for the radius. We get pi times 5 squared, or 25 times pi square centimeters. If we are approximating, we can say 25 times 3.14. That will give me a value of 78.5 square centimeters. And so now we can round up to 79 since that decimal place is 5 or above. So 79 square centimeters. And number 6, this one is not like 4 or 5 because it gives us the whole length across, which is the diameter. But for the area formula, we need the radius. And we know the radius is half of the diameter, so this should actually just be 1 meter here. We'll substitute 1 in for the radius. 1 squared is 1, so we have 1 times 3.14, which is going to be rounded to just 3 square meters. Now, finding the area of a sector. So in the vocabulary, we talked about sector being a part of the circle. So think of it as a part of the whole. And sometimes you can see this being like a slice of a piece of pie. If we want to get the area of just that slice, we know it's not going to be the whole area, so we're going to use proportions to solve for that missing part. And so here we know that the whole area of this circle is going to include a radius of 10 in the formula, so pi times 10 squared. When you end up rounding, you get 314 square yards. Now we want to find the area of the sector. We know that the entire circle is 314 square yards, but we know that this is only part of the circle, and we want to find that shaded part, that area only. And so now we'll use the area of the sector over the area of the entire circle equals the measure of the central angle over the measure of the entire circle. So we're using these values to find our missing sector area. So when we plug in those numbers, we don't know the area of the sector, so x goes in that spot. We know the area of the entire circle is 314. And now we know that this is only 55 degrees of the circle, and we know an entire circle has 360 degrees. So 55 out of the whole part, is 360. And we can cross multiply and solve for x here. So we get 360 times x equals 17,270. And when we divide by 360, we would get approximately 48 square yards for the sector. Now, the sector should be smaller than the entire circle, okay, the entire area. So if you get a number bigger than 314 or half of 314, because this is not half, then you know you've done something incorrectly. So, I always teach this as the part over the whole. So we're looking at the part which is the sector, the part area over the whole area, and we know it's proportional to the part degree of the circle over the whole degree. I always say, well, part over the whole. Now, so from here, I need to get the area of the whole circle, okay? So I don't know the part area, this sector area. I don't know this portion of the circle, so I'll put an X there. I know the whole area would be pi times the radius squared. The part degree, the sector degree, is 150 degrees, not quite 1/2. The whole, the number of degrees in a circle, is 360, and then we would cross multiply. Now, we might want to simplify this. And in the previous example, we had approximated the area here, and so we could do that here, or we could type it all and get an exact answer. So what I like to do is, well, I know this is 25 pi, and I like to keep it in terms of pi if possible. So I would say x times 360, or 360x, and then cross multiply here, we get 25 times 150 times pi, or 25 pi times 150. And so you would type that entire thing in your calculator, 25 times 150 times pi, and that gives you about 11,781. And from there we would divide by 360 to find that part area, to find the sector. And so we get 32.725, so that'll round up to about 33. We're talking about square meters. Alright, the next one, number 8. Remember, we're going to do the part over the whole. So the part area we don't know, so we'll put X there. The whole area we know would be pi times the radius squared, pi times 7 squared in this case. The part degree is 100 over the whole degree, 360. So we're only looking for that part. Cross multiply, we get 360x equals, well here, we know that this would be 49 pi. So it would be 49 times 100, or times pi times 100. And we could go ahead and simplify that right side if we want to round here. 49 pi 100. That's about 15,394. Divide by 360 to solve for x. So my 360s cancel, and when I divide by 360, I get, what is it, approximately 43, we're talking about square centimeters. And the last one, number 9. So we have the part area we don't know, x, over the whole area, pi times the radius squared, equals the part degree, 90, over the whole degree, 360. We know that 3 squared is 9, so this will be 9 pi here, cross multiply, and when I do that, I get 360x, 90 times 9 pi, and we can round on this right side. 90 times 9 pi, we get about 2545. Divide by 360 now. So here we're going to get 45 divided by 360, about 7 square feet. Now, the other way you could have looked at this is if it's 90 degrees, there are 4 parts of this pie that are 90 degrees apiece. And so you could take the whole area, this 9 pi, and divide it by 4 because there's 4 pieces. And that would still get you the same answer. And it would probably be quicker if you noticed that. So this is 1/4 of the pie, so we could take the area and divide it by 4 in this case.